Hello friends, today we are having another topic of the respiratory system, and that is the chemical regulation of respiration. The demand of tissues of the oxygen and the production of CO2 by the tissues, it goes on changing. Sometimes it does increase, sometimes it does increase or decrease also. But still the sufficient amount of O2 is delivered to the tissues, and sufficient amount of O2 is carried by the tissues to the lungs, and ultimately it is delivered. That means that the respiration is regulated precisely in such a way that the demand of oxygen of the tissues is fulfilled, and also the whatever CO2, extra CO2 is produced, that is then taken out of the body to the atmosphere. So thus this regulation of respiration, how does it occur then? It occurs by two mechanisms. The first mechanism, it is known as neural mechanism, and the second mechanism, it is known as chemical mechanism. In the neural mechanism, the respiration is regulated by central nervous system with the help of one center known as respiratory center. Whereas in case of chemical regulation, the chemicals present in the blood, by acting on the respiratory center, they regulate the respiration. So this is how now today we are having the discussion on the chemical regulation of respiration. Question arises, what are the chemicals that are regulating this respiration? The answer is the three chemicals. One, carbon dioxide, second, hydrogen ion, and the third one is the oxygen. These are the three chemicals which regulate the respiration. Now, how do they regulate the respiration? They regulate by acting on the receptor, and the name of that receptor is the chemoreceptor. So, what are the chemoreceptors? Chemoreceptors are the receptors which sense the change in the chemistry of the blood in our body. Now, the next question does arise, where these chemoreceptors are present in our body? The chemoreceptors, according to their location in our body, they are present at two sites, and thus they are named as central chemoreceptor and the peripheral chemoreceptor. Central chemoreceptor means the chemoreceptors which are present in the central nervous system. Peripheral chemoreceptors mean the chemoreceptors which are present outside the central nervous system. Now we come to what are the central chemoreceptors and where are they present. This is the medulla oblongata, this is the ventral surface, this is the dorsal surface. Downward we are having the spinal cord. Central chemoreceptors, they are present just 2 mm beneath the ventral surface of medulla oblongata. I repeat, central chemoreceptors, they are present 2 mm beneath the ventral surface of medulla oblongata. The area that is occupied by this central chemoreceptor is known as chemosensitive area. What it is called? It is called chemosensitive area. These central chemoreceptors, in turn, they are in contact with the respiratory center, and that is mainly the dorsal group of respiratory neuron. Then, these central chemoreceptors, they are stimulated by only one stimulus or by only one chemical, and name of that chemical is the H+ ion. So what is the primary stimulus for the central chemoreceptor? Primary stimulus is the H+ ion. Now we come to the another set of chemoreceptor, that is the peripheral chemoreceptor. Peripheral chemoreceptors, they are mainly present, number one, in the carotid body, number two, in the aortic body, and some vessels of the thorax, and some vessels of the upper abdomen. These are the locations of peripheral chemoreceptor. But they are more aggregated into the aortic bodies and the carotid body. This carotid body is present at the bifurcation of the common carotid artery. This carotid body is supplied by small nerve. Name of that nerve is the Hayes nerve. This Hayes nerve then joins the major cranial nerve, that is the glossopharyngeal nerve, and it enters into the medulla oblongata. Aortic bodies, these are 2 to 3 in number. they are innervated by the aortic branches, and these branches then join and ultimately enter into one major nerve, that is the vagus nerve, and this vagus nerve is also entering into the medulla oblongata. Remember here, these nerves, they are entering into the medulla oblongata, but they are not directly going into the dorsal respiratory, they are not directly going into the respiratory center. They are going into one receptive area, and that area is nothing but the nucleus, and name of that nucleus is the nucleus tractus solitarius. And from the nucleus tractus solitarius, information is then sent to the respiratory center, also it is sent to the vasomotor center, and accordingly the respiratory activities are altered, and by vasomotor center the cardiovascular activities are also altered. So all these nerves, they are entering into the common nucleus, and that is the nucleus tractus solitarius. Now, what is present in this carotid body? If we study the histology of this carotid body, we get one special type of cell, and this special type of cell is known as glomus cell. What it is called? It is glomus cell. And this glomus cell is said to be a chemosensitive cell. That is, it senses the change in the chemistry, and ultimately it is then stimulated. When this glomus cell is stimulated by change in the chemistry, the vesicles are present in the glomus cell. They release one chemical. Name of that chemical is the dopamine. This dopamine then acts on the free nerve endings, and this free nerve ending then join the vagus nerve and ultimately join what is called the velocopharyngeal nerve. Now, how these peripheral chemoreceptors are stimulated? Peripheral chemoreceptors are stimulated by three stimuli. Number one, decrease in the partial pressure of O2. Number two, increase in the partial pressure of CO2. And number three, increase in the hydrogen ion concentration. That means all the chemicals, they are stimulating the peripheral chemoreceptor. But out of these three chemicals, which is the stronger stimulus for this peripheral chemoreceptor? It is decrease in the partial pressure of O2. So primary stimulus or the major stimulus for the stimulation of peripheral chemoreceptors, it is a decrease in the partial pressure of what? Oxygen. CO2 and H+, they are the minor stimuli in this case. So this is about the arrangement for the regulation, chemical regulation of respiration. Now we discuss how these chemoreceptors, they work and ultimately led to regulation of respiration. This is the medulla oblongata. Inside the medulla oblongata, we are having many capillaries, and through these capillaries, the blood is flowing. To make the matter more simple to understand, we take out one capillary and we draw this capillary over here. And now we come to our next discussion. How these central chemoreceptors are stimulated? They are stimulated by only one stimulus, and that is the H+ ion. Now we do one experiment. In that experiment, we increase the concentration of H+ ion in our body. A state of acidosis is developed. When the state of acidosis is developed, we assume that as the concentration of H+ ion is increasing, there is linear increase in the ventilation. This is our expectation. That is, as the H+ ions are increasing, as the concentration of H+ ion in the blood is increasing, there must be the simultaneous stimulation of the central chemoreceptor, stimulation of the respiratory center, and there should be the linear increase in the ventilation. But we do not get such result. What happens in the state of acidosis? We get very late response. not only it is late, but it is also slow response, and ultimately it goes on increasing and it increases mildly and does go on falling. Now the question is, even though the H plus ion is the primary stimulus and even though there is the acidosis in the blood, why there is no linear increase in the respiration? The reason is that these blood capillaries, they are having the blood-brain barrier. Through this blood-brain barrier, H plus ion cannot cross this blood-brain barrier very easily. So they move very slowly, and that is why there is no linear increase in the ventilation. Now the question is, how these H plus ions are then made available in the cerebrospinal fluid? The H plus ions are made available indirectly by what is called the carbon dioxide. Carbon dioxide, it crosses the blood-brain barrier as if it is not existing. Why? Because all the cell membrane in our body, they are 20 times permeable to CO2. So CO2 easily enters into the cerebrospinal fluid, and this CO2 then combines with the water and it forms what is called the carbonic acid, that is H2CO3. H2CO3 now it dissociates into H plus ion and the bicarbonate ion. H plus ion thus form, then they act on the central chemoreceptor, stimulate them, which in turn stimulate the respiratory center, which in turn stimulate the ventilation, and there is increase in the ventilation. So who is now the powerful stimulant? Now, we do one example or we do one experiment wherein what we do, we increase the partial pressure of CO2 in our blood. And what is seen, and we see what is the effect of that increasing partial pressure of CO2 on the ventilation. So here, as the partial pressure of CO2 is increased, there is immediate increase in the ventilation and it is increased by many times. So we are getting immediate response by the CO2, but we are getting very late and less response by the H plus ion. So both of them, they are now working together. H plus ion, it is having its own limitation. H plus ion, they are dependent on whom? They are dependent on the CO2 for their production. So the primary stimulus for the chemoreceptor is the H plus ion, but the secondary stimulus is whom? It is the carbon dioxide. This is it. Now, we continue our experiment. That is, CO2 is increased into the blood, and what we get tremendous increase into the ventilation, and still the CO2 is kept elevated. After 24 hours or 24 to 36 hours, the ventilation goes on decreasing. In spite of elevated CO2 level, ventilation is now decreasing after 24 hours. What is the reason? Reason is that this CO2, as the CO2 in the blood is increased, it combines with water in the plasma of the blood, and it leads to formation of carbonic acid. This carbonic acid, though it is unique acid, but since it is present in plenty, now it leads to development of what is called the acidosis. After 24 hours, body cannot handle this acidosis because the metabolism of the body now starts disturbing. And to correct acidosis, another system comes into the operation, and that system is the excretory system. This excretory system, it now starts excreting the acidic urine, and it now starts the retention of bicarbonate ion, and there is also the new synthesis of bicarbonate ion. So bicarbonate ions are being retained, they are being newly formed, concentration of bicarbonate ion is increased, and they nullify what is called the H plus ion, and thus acidosis is then now corrected. At the same time, some bicarbonate ions, they enter into the CSF and they combine with the hydrogen ion and they neutralize the hydrogen ion. That is why after 24 hours, even though the partial pressure of CO2 is kept elevated, there is decrease in the response. So CO2 can exert its effect on the ventilation for only 24 to 36 hours. Later on, its effect on the ventilation goes on decreasing. Next, central chemoreceptors. Remember, central chemoreceptors are never stimulated by oxygen, that is fall in the partial pressure of oxygen. So central chemoreceptors are stimulated by primary stimulus, that is the H plus, and secondary stimulus, it is the CO2, and they are never stimulated by fall in the PO2. So this is about what is called the role of central chemoreceptor in the regulation of respiration. One more thing I like to point out here is that whatever reaction that is occurring into the cerebrospinal fluid, same reaction occurs into the interstitial fluid. Hydrogen ions are also generated into the interstitial fluid, but since protein buffers are present into the interstitial fluid, these hydrogen ions are immediately buffer over there and they cannot exert, or they exert very little effect. Then which hydrogen ions are mainly stimulating the central chemoreceptor? Those who are formed into what is called the cerebrospinal fluid. So this is about the central chemoreceptor. Now we control what is the role of peripheral chemoreceptor. Role of peripheral chemoreceptor in regulation of respiration. As stated previously, peripheral chemoreceptors, they are stimulated by one primary stimulus, and that is decrease in the partial pressure of O2. अब partial pressure कितना decrease होना चाहिए? And to understand that, we draw our oxygen hemoglobin dissociation curve. 9% of saturation of hemoglobin in oxygen, and here it is the PO2. At the value of the 60 millimeter of mercury of oxygen, the hemoglobin is 90% saturated. At 95 millimeter of mercury, it is around 97% saturated, and this is our curve. For the stimulation of peripheral chemoreceptor, the PO2 should fall below 60 millimeter of mercury. Then and then we get the visible changes in the ventilation. Why it should fall below 60 millimeter of mercury? The reason is that up to 60 millimeter of mercury, hemoglobin is still 90% saturated with the oxygen. It contains still sufficient amount, and that is why the fall in the PO2 is not sensed by the peripheral chemoreceptor. Now here we have two events. Here we are having two events. Number one event when the PO2 is fallen to exact 60 millimeter of mercury, and second when the PO2 is fallen below 60 millimeter of mercury. Exact 60 millimeter of mercury, one event, and below 60 millimeter of mercury, another event. देखो क्या होता है? When the PO2 is fallen to 60 millimeter of mercury, the hemoglobin is 90% saturated with oxygen. That means it is containing slightly less amount of oxygen when it is 100% saturated. This reduction in the oxygen level in the blood, it slightly stimulates the peripheral chemoreceptor. Stimulating the globus cell, signals go through these nerves into nucleus tractus solitarius, which in turn stimulate the respiratory center, which in turn stimulate the ventilation, and ventilation is increased by 2-fold. Ventilation is increased by 2-fold. Now, because of slight increase in the ventilation, there is not only more intake of O2, but simultaneously there is more washout of the CO2. And as the CO2 is being washed out, less CO2 is available into the CSF, less formation of H plus ion, less stimulation of the central chemoreceptor, less stimulation of the respiratory center, and the ventilation then goes on decreasing. तो पार्शियल प्रेशर ऑफ O2 ने जो वेंटिलेशन को स्टिमुलेट किया था, इट इज देन डिक्रीज्ड बाय द PCO2. This effect is known as braking, or it is known as braking effect of CO2 on decreased PO2. That is, पार्शियल प्रेशर ऑफ ऑक्सीजन ने जो वेंटिलेशन बढ़ाया था उसको किसने कम किया? दिस इज डिक्रीज बाय व्हाट इज कॉल्ड द CO2. Why so? The reason is that among the two receptors, central and the peripheral receptors, 80% of the chemical regulation of respiration is done by central chemoreceptor, and only 20% is done by whom? It is done by peripheral one. That is why CO2 is very important in determining or in regulating the respiration. So, now second event, if the PO2 is fallen below 60 mm of mercury, what will happen to the respiration? There is a stimulation. When the PO2 is fallen below 60 mm of mercury, there is less amount of oxygen present in the blood. That causes strong stimulation of carotid and the aortic bodies. Strong signals go to the nucleus tractus solid areas, and it causes strong stimulation of the respiratory center. Ventilation is increased by 7 to 8 fold, and during that braking effect may come, but that braking effect is then overridden, and ultimately there is increase in the ventilation, and that increase in the ventilation is by 7 to 8 times. So that is why the effect of PO2 to be visible, on the effect of PO2 on the peripheral chemoreceptor to be visible, for that PO2 should fall below 60 mm of mercury. 60 पर गए तो ब्रेकिंग इफेक्ट, above 60 पर रहा तो नो इफेक्ट, वेंटिलेशन इट इज as usual, that is the normal one. These peripheral chemoreceptors, they are also stimulated by slightly by increasing the PCO2 and also slightly by increasing the H plus ion. So this is the role of what? These are how the peripheral chemoreceptors they work. Now the question is, out of these three chemicals, which chemical is the major regulator? Of course, it is the CO2 is the major regulator of respiration. Why? 4 reasons. Number 1, CO2 can cross the blood-brain barrier very easily. CO2 enter into the CSF, combine with the water, forming the H plus ion and making the primary stimulus available for the central chemoreceptor. And these central chemoreceptors, they regulate 80% of respiration by the chemical. So this is the one factor. Second one is that the CO2 is very easily diffusible. Third factor, CO2 can stimulate peripheral chemoreceptor also. And fourth factor, which is not the actual reason, but CO2 pulls the leg of O2. That is pulling of the leg, and that is known as what? Braking effect of CO2 on the partial pressure of O2. So that makes the CO2 the better regulator of respiration. Very often we see in the hospital or in the ICU, the oxygen patient is put on the oxygen therapy. The mask is there attached, and it is then attached to the oxygen cylinder. Is it that this oxygen cylinder contains only oxygen? No. It contains oxygen, but simultaneously it also contains CO2. So oxygen is correcting the fall in the PO2, but what is the use of this CO2? The use of CO2 is that as this CO2 enters into the body, this CO2 tries to stimulate the central chemoreceptor, which stimulate the respiratory center, and the normal respiration it now comes back to the respiration comes back to the normal state. We cannot put the patient for long time on this oxygen therapy. We have to shift the patient from the oxygen therapy to the normal respiration. And this is done by whom? This is done by the CO2 that is present in the oxygen cylinder. That CO2 stimulates the respiratory center via central chemoreceptor and tries to resume the normal respiration of the patient. So this is all about the chemical respiration. Central chemoreceptors are more powerful than the peripheral chemoreceptor. Among the peripheral chemoreceptor, carotid and the aortic bodies are present. Among them, carotid body is 7 times more strong in regulating the respiration. So this is all about the chemical regulation. Thank you very much.